You're muted, Akansha.
Oh, okay. So how are you doing?
I
We
am
are on
doing
a live stream
well.
after we are on a live stream after a few weeks now. So pretty
It's almost been
excited.
like, almost feels like 2 months. It's been a while, but
Yeah.
we're back at it. We've got a different approach for this live stream this time. We're going to focus in on how some of our awesome engineers out there in the world are solving some real
Hmm.
world problems. And it's not just about tech, it's about culture, it's about process, it's about the
Hmm.
decision making, the emotional side of it too, and all the thought process and collaboration that has to go into a solution versus, hey, here's some tech, here's what it does, here's how cool it is. It's the end user
Yeah.
stories behind the keyboard. So
Yeah,
I'm
that's why
excited.
I personally like this stream series that we are starting up, and this is our very first episode with Sanaa and Rosa. So I'm like very curious to know like how did they do the Kubernetes upgrades like for their Kafka, and what problems they face and what are the challenges and solutions they went for. And yeah, and also like KubeCon is coming up in about 2 months. So in like Salt Lake City in Utah. So will you be there?
I
And for
will.
those of you, oh yeah, and for those of you who don't know what KubeCon is, it's like a CNCF flagship conference which happens like twice in a year in Europe and US, and this time it's happening in Salt Lake City, and I will be there. I'm like very excited to talk to the end users there, the maintainers. Love to see the demos of the open source projects, of course, and you get to interact with the community. So I will like share the link in the chat and people can just look it up what this conference is all about. So yeah.
Yeah, awesome. And I just want to say a hello to Andrew Brown. Thanks for coming by. Andrew makes some awesome cloud content across different cloud providers. So if you're ever interested to really see the depth at which he goes into, go check out some of the stuff he's been doing. Now, having said that, I'm going to bring up our guests, Sana and
Mhm.
Rosa from Shopify. So let's add them to the stage. Welcome, welcome, welcome. How are you both
Everyone,
doing?
Hi
doing
everyone.
good. How are you doing?
We're doing well, and thank you for being our very first guests, or for our very first episode of Behind the Keyboard. So I want to get right into introductions. Everyone knows who Akansha and I are, but we want to know
Mhm.
who Sana and Rosa are. So Sana, why don't you give us an introduction, a little bit of a backstory of your tech journey and how you got into Kubernetes?
For sure. So my name is Sanaa. I'm currently working as an infrastructure engineer at Shopify. Rosa and I are actually on the same team, and we work on building and maintaining Kafka and Flake infrastructure. My tech journey started back when I was in high school, and I got interested in taking the computer science classes at my school. And from there, I started doing different co-ops and experienced a bit of every side of tech. So I did backend engineering, mobile, infrastructure engineering, and data science, and ended up really just loving the infrastructure space and learning about the cloud, and also Kubernetes. I was able to attend KubeCon last year, and I really got interested in the whole open source field for Kubernetes. And from there, I just wanted to get more involved, whether it was with CNCF or just doing more technical talks in Kubernetes and including that with my job. So yeah, it's like pretty much my tech journey. I've been full time for almost 2 years now.
Fantastic. Thank you so much for sharing that, Sana. I do have a question for you. What is it about Kubernetes that a lot like attracts you to keep working on it continually?
I honestly have to say it's the community. I feel like there's always so much being worked on, and a lot of these people do it outside of their regular day-to-day jobs. There's just such a huge passion and motivation for building and continuously building on this space. And it's also just super cool to see how other people implement Kubernetes for their use cases. But yeah, I honestly have to say like the people have made the most of my experience.
Fantastic. All right. Well, let's bring up Rosa.
Yeah, hi everyone. I'm with Sanaa on the streaming platform team at Shopify. My tech journey started out also when I was in school. In university, we had a container orchestration class, and we talked about Kubernetes and some of the theoretical components behind it, and I thought it was really interesting. I was also able to do different internships and co-ops where we actually worked a little bit with Kubernetes and stream processors and connectors. So I thought that was pretty interesting. And when I got into full time, I was able to join the streaming platform team, which was really cool, so that I could work on similar technologies. What I like about this space is that there's so many, we're working on different problems all the time, and the space is so large, and we get to really collaborate and drill down on how to solve different problems that impact or that have a really high impact for users. So yeah, that's kind of how my tech journey started.
I love that. Thank you so much for getting into that journey. I wanted to know, what was some of the most interesting aspects of Kubernetes that you've encountered, while working on it?
I would say that for me, the most interesting part is that it really kind of pulls you into solving getting your head diving first into sometimes we end up going into the source code and seeing that other people are facing this problem, and kind of what Sana said, the community is so large, and so I find that it's really interesting that a lot of people are trying to solve common problems within Kubernetes, and it makes it nice to work with because we have that whole community, but also it definitely, there's a lot of enjoyment in working with it too because of that.
I love that. Okay, so one more question for the both of you before I kick it off to your presentation. What would you do if Kubernetes wasn't around? How would you achieve the same kind of workflow and operations? What tool would you use in place of that?
That's a tough question. I mean, there's a lot of container orchestrators out there. None that I can think of off the top of my head. But I'm sure there would be some kind of alternative that we might be able to use. Or we might just build it in-house.
That's Rosa, do you have an answer for that?
My first thought is I don't know, look into Docker or trying to build up some sort of alternative. But yeah, I think it would be definitely a tricky one.
Yeah, there are solutions that exist out there, but I think that for what Shopify does, I think Sanaa hit it. You would definitely probably build it yourself or find a way to automate workload deployment and orchestration, and not be specifically tied to CNCF or even Kubernetes for that matter. But having said that, I'd love to bring up your presentation and talk a little bit about the other side to it. We've got Kubernetes already running in production, and then there are artifacts and systems that run on top, streaming systems, specifically Kafka. And when you're running Kafka, you're doing things at scale. And not only that, you also have to operationalize it and go through upgrades and lifecycle management. You have to patch it when things are broken because of a vulnerability, or could potentially break because of a vulnerability. So I'm excited to get into this. I'm going to pass the stage over to you, and I'm going to kick us out so you both can present and go right for it.
Cool. So today we'll be talking about how we streamline Kubernetes upgrades for Kafka at Shopify. And you could connect with us on LinkedIn or find us on X. But I'm an infrastructure engineer at Shopify on the Streaming Foundations team. Some of my hobbies include reading. I really like snowboarding, and I also really like animals. I have a cat at home.
Yeah, a little bit about me is that I love to write. Anything from essays to short stories. I grew up playing soccer, so I still love to do that, and I absolutely love to travel.
Cool. So we'll start off with a general overview on the basics of what Kafka is and its infrastructure at Shopify, as well as how we do Google Kubernetes engine upgrades for clusters that run Kafka. And we'll be talking about what we did to speed up this upgrade process.
Starting off, what is Kafka? So Apache Kafka is a publish subscribe model for real-time data stream processing. And what that means is that it's a system that exchanges messages between the publishers, so those that create and send messages, and then subscribers, which are those that receive and consume those messages. So in Kafka, those messages are stored into a category specifically called topics, as you can see in this diagram here. And multiple producers and consumers can interact with this single topic simultaneously. So say, for example, the Olympic Games, they just finished. They're going on across the world, and I want to be able to see the real-time information for the gymnastics tournament, for example. So I'll be able to see that whether it's on Google or on YouTube or anything like that. And essentially in the Kafka sense, the Olympics, it'd be producing to a topic. And then as a consumer, which is my phone or my computer, I'd be able to see that in real time. And to bring that back, the system essentially takes the updates, it writes those updates to a queue, which in this case is the topics, and then there are downstream processes that consume from these updates and display it on various channels, such as my phone, computer, just an example. So at a high level, these topics live in a Kubernetes cluster, which many producers and consumers can interact with, as you can see in this diagram. So now when you add Kubernetes in the mix as well, it looks something like this. It's made up of 3 parts. We have the producer, which can be referred to as a client. It writes to a broker-specific topic. The broker itself is a server. It stores those messages in topics and manages the read and write requests for data. And finally, we have the consumer, which is also another client, and it reads from a broker-specific topics. So since we have it on Kubernetes, we can leverage the horizontally scaling option depending on how much traffic we get for a specific cluster.
Yeah. As Sanaa mentioned, messages are stored in topics, and topics are further split into partitions, which is just a section of the topic. Partitions are spread across brokers in a cluster, allowing horizontal scalability, and Kafka replicates the partition for fault tolerance. We often use a replication factor of 3, achieving 3 backups. And of all copies of a partition, only one is considered the leader, which handles all the read and write requests of that partition. For example, you can see here topic A has 3 copies of partition 0, which are in broker 1, 3, and 4. And the leader, which is bolded for this partition, is in broker 1. To expand on this, here we have a Kubernetes cluster deployed to the US East region that has a default of 3 zones, A, B, and C, as defined from Google Cloud Platform. Each Kafka broker or Kubernetes pod is always in a zone within the region. Kafka spreads these partitions across these 3 different zones in order to minimize data loss in the event that a zone goes down. This is a feature from Kafka that we enable where we use these zones from GCP as racks so that we can achieve Kafka rack awareness in our clusters. And this essentially just ensures that no 2 replicas are on brokers in the same zone or rack. Kafka also ensures that we don't have a scenario like this. This example shows that for topic B, we have 2 copies of partition 0 in zone A. In the event that zone A goes down, it risks having only 1 copy of that partition, which is in broker 4 in zone C. So it's not as resilient.
So now that we've covered the basics of Kafka, here's some fun Kafka stats about Shopify today. So at Shopify, we use Kafka for log ingestion, for change data capture, which is tracking changes made to data in the database and delivering those changes in real time. We also use it for stream processing using Apache Flink. tracking product updates on our shop app, and for webhook delivery. So overall, we have 1,194 Kafka brokers spread across 17 clusters, more than 200 clients across Shopify. And on average, we get about 19 million messages in per second, and to all those different topics that we talked about. And then on average, we also have a disk usage of more than 2 petabytes.
Now we talk about a little bit more of like components in the Kafka cluster. To preface, we use Apache Kafka version 3.7, and we self-manage our Kafka infrastructure. Diving deeper into what that may look like, here's a Kubernetes cluster in the US East region. Under the Kafka namespace, we have a Kubernetes stateful set with our Kafka brokers, also represented as Kubernetes pods that are provisioned in 3 zones. Our Kafka clients are producers and consumers that create traffic to our clusters. And we also use open source dependencies such as Kafka Monitor for observing availability and latency, Zookeeper for broker coordination, MirrorMaker that copies over data when needed, and Cruise Control for automatic rebalancing and self-healing of our Kafka clusters.
So bringing this back to Kubernetes, all of our Kafka brokers pull their configurations from a stateful set. And we use the stateful set over a deployment due to the stateful nature of how Kafka manages and stores its data. And we essentially want to save state since data is passed through. We require persistent storage, which is why we use persistent volumes. And in Kubernetes, persistent volume and persistent volume claim go hand in hand. A persistent volume being a piece of storage in the cluster, and then the claim is just a request for that storage by a user, which is our broker in this case. So the flow goes, you create a persistent volume, the persistent volume claim is created to claim that piece of storage and bind it to that volume. And then finally, you mount that volume to the pod through the claim. So all in all, we use a stateful set because we want to have ordered and graceful deploys. We use a rolling update strategy, so there's minimal downtime, and the pods are deleted and recreated in an order, since we name our pods from Kafka 0 to Kafka N, depending on how many brokers we have in the cluster. We scale the cluster in a rack-aware manner, so this also helps us with that. When we fail over traffic from one cluster to the other in case of any incidents, we essentially move the traffic. We route the traffic going from one cluster to another. It also helps us maintain the state of those topics and partitions. And finally, there's no data loss when a Kafka pod is rescheduled onto a new node, because the persistent volumes are also just attached to the new node, which is vital for our upgrade process that we'll cover in the next section. So section 2 is talking about our upgrade process. Why do we even do upgrades, and how often do we do them? And also, why do we automate? We'll get more into the automation after we cover all the steps, but today our infrastructure across Shopify, we're using 1.28, and we're in the process of upgrading our GKE version to 1.29. We do these upgrades twice a year, usually skipping the odd versions, but we like to take advantage of all the latest features, any bug fixes, and all the versions that Google has to offer. Overall, these timely upgrades are pretty important since we like to keep our infrastructure up to date.
We have in-house automations created that are used to upgrade the Kubernetes version for our Kafka clusters. Since Kafka brokers are stateful and we want minimal disruption for our clients, we take the approach of creating a new Kubernetes cluster from a predefined template using the desired Kubernetes version. And we essentially migrate the stateful set from the old cluster to the new one. This automation is kicked off with a proposal that you can see here, where we specify the Kafka cluster that we want to upgrade, the region, as well as the custom feature below that enables migrating the stateful set. Once you have a team member approving this request, it starts running the tasks involved. For example, this is just a screenshot of our automation showing us in a Slack thread the individual tasks that are running. Once the new Kubernetes cluster is spun up, everything outside of the Kubernetes default, such as Zookeeper, Kafka namespaces, pods, and disks are created. And the automation triggers a bootstrapping step that deploys resources and dependencies for the Kafka cluster in prep for the migration.
So like Rosa mentioned, here's the template for one of our persistent volumes. So as you can see, like the naming is related to the pod name. And based on this is what we use to provision. And if you go to the next slide, we'll see in the current cluster, you have all the pods up and running, and the name of the pod also matches the PVC. And so they're bound to the current, they're bound to the current cluster. And then in a new cluster, you see the pods have started to provision, they're initializing, they're in the init stage, but the PVCs are still bound to the old cluster.
When it's time to migrate the Kafka stateful sets between two clusters, we start scaling down the stateful set one by one in the old cluster, deleting a pod each time. Going into that, each time that a pod is deleted, the persistent volume claim is released, and we wait for the corresponding pod that was initializing in the new cluster to begin running, since the pod can now use the claim. So this diagram shows that pod 3 in the new cluster is able to start running because the associating persistent volume claim has been freed up. And since in this case we have one Kafka broker running in the new cluster, this cluster can begin to serve traffic and requests. We sequentially continue this process until no pods are running in the old cluster and all the pods are now running in the new cluster.
So TLDR of that, we start off by creating a new Kubernetes cluster. We provision the Kubernetes resources that we need, such as services, pods, all the namespaces that we require. We then scale down our cruise control, mirror maker, and Kafka monitor to have minimal disruption on our SLOs during that time. We migrate the Zookeeper brokers first, and then we follow up with migrating the Kafka brokers using the process that Rosa just described. And then finally, once all the new cluster is up and healthy, we've checked all of our alerts and all of our dashboards, we can decommission the old cluster. So now coming back to the question of why we automate. We automate because there's a lot of moving pieces. There's a lot of code that lives in across multiple repos, whether that's our network, our templating, our Google configurations, and other services that we also deploy to the cluster. So they all live across different repos, and when we're making these kind of changes, we want to make sure that we provision all the services at the same time. When it comes to things like our network, changing that can be time-consuming and also is a careful process that we want to reduce manual intervention as much as possible, since even just modifying something like a notification for a cluster can alter the shape of the cluster. And also, finally, it saves us a lot of time. Historically, we actually used to copy the data over the network, and now we reuse our disks. Finally, the process that we're like looking at talking for this is a speed up process that we did. So the whole process of detaching a persistent volume from a pod, scaling down, and then reattaching the persistent volume to the new pod in the new cluster takes about 5 to 7 minutes. Take that time, and if you multiply that by the size of our production clusters, which can be upwards of maybe 200 brokers and more, it takes more than 23 hours. We've let our automated upgrades run over the weekend and past business hours, which definitely heightens the level of our monitoring for our team and to make sure that things are running smoothly. And we do have an on-call available for our team, but we'd like to have minimal disruptions for them as much as possible outside of business hours. Overall, pretty slow.
To talk a little bit more about how we sped the process up, if we recall Kafka's rack awareness support, Kafka ensures that no two replicas of a partition are on the same rack. So that essentially means that we could delete all the pods in a given rack or zone at the same time while still maintaining high availability of our topics, because we can guarantee that each partition will still have 2 available replicas. We can use that approach in the stateful set migration, where we delete all the pods in a zone, wait for the corresponding pods to start running in the new cluster, and then we can move on to the next zone. So that kind of looks like this. And now the upgrade can scale by the number of zones, which is always 3, compared to scaling by the number of pods. This is a screenshot where we migrated the stateful set in a Europe cluster during an upgrade. We used a script that grouped brokers by zone, and we deleted all the pods in the zone at once. As mentioned, we wait for the corresponding set of pods that were deleted, are now running in the new cluster before we move on to the next zone.
Here's an example. We had a cluster where we had 180 brokers, and using the old version where we detached the pod and the PVC and then moved it to the new cluster, it took about 15 hours because each broker took about 5 minutes. And with the zonally restarting method, it took less than 45 minutes. Right now, this is done through a script since it's still a risky task to do, but we are currently working on potentially even automating this process. So yeah, that's the end of our presentation, and thank you so much for listening, and we are ready for any questions.
I need to unmute myself. Okay. So, you mentioned that you were able to speed up that migration, right? And you spoke a little bit about the details about that. What were the downstream impacts of that as well? Like, who were some of the other teams that got to see the benefit of that migration time shrinking?
For starters, like during our migration, in order to basically just like have no impact on our clients, we do fail over the traffic from one cluster to the other. But we also have clusters where we won't be able to do that failover since like it's stretched, for example, or if it's like a single cluster with no other regional pair. So overall, it's just a faster process. So instead of having a longer maintenance window, it is like shortened to like an hour. Do you have anything to add on that, Rosa?
Yeah, I was just going to mention the maintenance window part. It's not super ideal to be in a maintenance window for like 15 hours and waiting for different pods to show up one by one. So having this sped up so that we could do it like within 1 hour makes things a lot easier for us. Also during upgrade windows, we do upgrade multiple clusters, and we do try to focus on one at a time. So it does really help speed our process up.
So Sanaa and Rosa, like it was a great presentation. I really enjoyed it. So I had like one question, like how do you like ensure minimal to like zero time downtime for like Kafka services during these upgrades? Because like Shopify does it like real data time handling.
Yeah, it mainly comes down to the failovers. So when we are upgrading our US East 1 cluster, for example, we fail over the traffic to the US Central cluster. And it's just like our method is that our clients do know that this is, they kind of like almost like subscribe to being failed over. And so at all times they have their topics in the other cluster and they have consumers in the other cluster, so they're able to have see like no impact. The most that they might see is like potential reconnections, but otherwise like we are resilient on that front.
Okay.
And to add on top of that, our upgrade processes ensure that the Kafka cluster is still up and running. So we have brokers that are serving traffic at all times. So that also helps with like minimal disruption to our clients who are sending traffic to our clusters.
Mm-hmm. Okay, that answers my question. And just one more question, like what kind of monitoring do you have in place to like catch issues during upgrades, and like how do you handle rollbacks in case something goes wrong?
Some of the monitoring that I would look at is that one is like just making sure that all the pods are still like running and are coming up one by one. Try to look at things that such as like produce request times, and also that there's no like errors in terms of serving requests. So we have alerting for that, making sure that like the cluster isn't like degraded by any means. Yeah, Sana, did you have anything to add for other monitors?
Yeah, we have a lot of Kafka-specific alerts, such as like checking if there are partitions that are under-replicated, so like pods aren't coming up. If there are pods that are unready, so you might have noticed in one of the screenshots, like we had a pod that had like 3 out of 3 running. We have like 3 containers, so if any of those containers aren't up and running, we would be alerted. Yes, we rely pretty heavily on our dashboards. We have it set up to check a lot of things, and then also our alerts.
So like it's basically the in-house monitoring tools that Shopify uses for it, right?
Yeah, we've built a service based off of Grafana, so that's, and Prometheus, so that's what we use.
Okay.
So getting specific about Kafka, what are some of the ways that folks can adjust and look out for making sure that Kafka is running optimally? Like, how do you optimize it? How do you ensure that it performs correctly? The streaming doesn't slow down, etc.
Yeah, I think a lot of that comes down to one thing that Rosa mentioned was like produce and consume times. So keeping that as low as possible, and making sure that you have enough resources in the actual cluster, whether that's like your disk space or the CPU that you're using, because the more cores that you add, the more throughput that you get for Kafka. Overall, ensuring that the cluster itself is healthy in order to take those requests. Yeah.
Okay. Now, if folks wanted to understand how to even get to the point to use Kafka at scale, what would you suggest a path that they would take in terms of things that they should learn to be able to get to that, to your level, to be able to understand how to work with Kafka, migrate it, manage it, operate it, and so forth?
I would say that I think just getting pretty well acquainted within the concepts in Kafka. So we touched upon some of the Kafka support for rack awareness and how to make sure that we have resiliency of the data that's coming within our clusters. I think that was a pretty crucial bit for, at least for me, when I got started with Kafka, as well as just understanding how different pieces play together. So for example, like the producers and consumers and what happens and kind of the behind the scenes internals within Kafka was super useful to know, especially when debugging itself, as well as there's other dependencies and services that really help manage Kafka as a whole. So things like cruise control for automated rebalancing of clusters, Kafka monitor to just check any observability metrics and things that are going on. And with that, I think that just like really helped grow Kafka at scale too.
Yeah, I think Rosa pretty much covered it. One other thing that I would add is that there's like a pretty well-known Kafka operator called Streamzy that a lot of people use. So that's like a pretty good base. They honestly have like a lot of good examples. I know they also have amazing docs on just like talking about how to optimize things and such. And then there's also the Kafka community that's huge, and they have a bunch of threads on just like all these different questions. Yeah.
One more question I have, like how do you determine the optimal timing for upgrading the Kubernetes clusters? Like what factors influence your decision-making process? Like when you should go for upgrade and stuff?
Well, we have a team at Shopify that actually does test out these upgrades beforehand, before the rest of the teams at Shopify do upgrade. So they do a lot of that testing, clearing things out for us, and then when comes down to it, we do the upgrades like in Q1 and Q3. And in terms of the time, I would say things that we look at is just like how disruptive is it to the cluster. So we've tried like blue-green upgrades. We've done the upgrade process that we mentioned here. How does it impact our clients? What's the best way that we could do it in terms of like what should we automate, what shouldn't we automate? Because I think there's still some room to just have manual checks, and ideally in like a fast manner, but also just again like minimal disruptions.
All right, well, that's it for the questions. I don't want to keep loading you all up. It might be overwhelming. I have like a whole bunch. I'll probably get you on for a second stream at some point in time. But I want to thank you both for coming on and sharing a little bit about how Kafka upgrades are handled at Shopify and just the overall process, because I think it's important for folks out there that are even using this in their own production environments to just gain ideas on how they can go about it, especially if they're trying to operationalize different aspects of their workload environment and implement these like streaming capabilities as well. So one final question for the both of you, and then we'll be done. What's next on the learning plate for the both of you?
Just in general, like anything. That's a tough question. I think genuinely, I just want to do more things, whether it's in the open source community. I had an open source contribution a couple months ago to the customized package, but I'd love to be on the Kubernetes release team and to help out on that front. So I'm trying to learn as much as I can so I could be ready for that and apply.
For me, I think what's next to learn is just learning more about Kafka. I feel like with the frequent releases and even upgrading Kafka as well, as well as Kubernetes, there's always things that are being changed. I think for me, I always like to try to be updated with up and coming changes that could be possibly like innovative for our infrastructure, and that could really help improve like processes and stuff. So that's probably what's next on the list for me.
Marino, you're muted.
I keep doing this. I just want to say, oh my gosh, I'll never get over this, because I love the fact that we have double mutes, but it's a double-edged sword because of this. But I want to thank you both for coming by and sharing, your story, sharing a little bit about how to handle Kafka upgrades. And we hope to have you on another episode of Behind the Keyboard and User Stories. Akansha, any final words?
I really enjoyed the stream. Thank you so much for your journey and whatever problems you have been solving. And also that, like Sanaa mentioned, that she wants to be in the Kubernetes release team. That's also one of my goals, and I would be applying for it in January when the forms are out. And yeah, so I really enjoyed it, and we would love to have you for another episode in this stream for sure.
Thank you so much for having us.
Thank you so much.
Thank you. And one last thing, if folks want to find you and connect with you, where can they find you?
On LinkedIn, and we're both officially on X as of this year.
Awesome. Okay. All right. Go follow Sanaa and Rosa and connect with them. Take care, everyone, and we will see you on the next episode. See ya.